All right, so let's talk about RASP. Runtime Application Self-Protect. This is what Imperva RASP is all about. RASP gives you the ability to understand every aspect of the application runtime. What does that mean without being an application developer? It means you can understand all of the individual components and communication pathways within the application, how the application is communicating on each line of code within the application, and whether or not it should or should not be doing something within that code. What's unique about Imperva RASP is Imperva RASP uses something called LangSec, Language Theoretic Security. It's one of the primary reasons we felt, and even Forrester has felt, that Imperva RASP, previously known as Brevity, was the leader in this industry, not by a small margin, either by a very large margin. LangSec differentiates Imperva RASP from the other RASP vendors that are out there in some unique ways. I'm not going to get deep into LangSec here, but I'll give you some kind of a primer on it, if you will. At the end of the day, RASP is a library that's installed within your web application app server. If the app server runs Java, if the app server runs .NET, then Imperva RASP can support it. If it runs anything else, any other framework, then Imperva RASP won't support it. And this is an important topic to come back to later on when we talk about how RASP fits into the Imperva ecosystem. However, RASP is going to sit as a library right in the application. Number one, RASP does not require code changes. Imperva RASP introduces very low CPU overhead, approximately 2%, but the reality is if your application's already overloaded, we're not going to overload it any more than it already is. If it's not overloaded, we'll be generally transparent to the application. So there's really no impact here. We do all the things you would normally expect a web application firewall to do, things like SQL injection protection, cross-site scripting, remote file inclusion, even cross-site request forgery, all the standard stuff you'd expect a WAF to do. So when we think about Imperva RASP, the unique capacity in its ability comes back to taking this information from LangSec. LangSec says, I am not going to use what traditional WAF uses. I'm not going to use signatures. I'm not going to use regex to solve the problem of security. So that means that from an environment, a normal WAF is going to look for example, for SQL injection, a signature like or something equals something. LangSec is not looking for that. LangSec is looking at the actual string itself, looking at the entire SQL injection string and just seeing if there's anything that creates a equal environment, creates a true statement. We don't care what it is. It could be monkey equals monkey. If it's a true statement, it's a true statement. It's not a signature we're looking for 1 equals 1 or 2 equals 2 or 2 plus 2 equals 4. This is how traditional WAFs have to work. They have to look for very specific strings of characters. This is not how Imperva RASP operates. Imperva RASP looks for true statements in the SQL code. The result of this is that you wind up with an environment where when traffic comes in, Imperva RASP can inspect that traffic, dig into the actual SQL code in the back end. I'm using SQL as the example here, but SQL code in the back end, and look for what's called a tautology, and that's essentially a true statement somewhere. And well, not just a true statement, but an always true statement. There can be true statements all the time in SQL language, but not always true statements. Those are a key indicator of an attack. And so what's nice about this is, even if there's a new attack on the horizon, if there's a new 0 day that happens, if that 0 day creates a tautology, an always true statement, I don't need a signature for it. I don't need to update anything. RASP has it. And so this is how it works for SQL injection with RASP. In a similar way, though not exactly the same way, this is how it works with cross-site scripting. There's a couple of different mechanisms that work for remote file inclusion and the other types of attacks that we happen to have. But the fact here is it's a markedly different technology than what traditional WAF has. Now, I'm going to wrap up here with why this matters to us at Imperva and why this was so compelling for us. It was compelling for us because when you think about something that's going to be deployed on the application, and number one being deployed on the application, it can see the two sides of our business, the data side and the app side. The data side is already interesting to us anyway, because that's another half of our business. But even on the application side, something that is different than what we do makes a lot of sense when you think about a security in depth strategy. So if you look at what we've talked about in the past, we've talked about Cloud WAF. Cloud WAF that we use today does use signatures. It does use regular expression, and it uses a few other mechanisms, but none of them are LangSec. If you look at Imperva on-prem WAF, it's been doing well for years. It's been the leader, both the Cloud WAF and the on-prem WAF have been the leader in the Gartner Magic Quadrant for years, but they do use signatures and they do use regular expressions. It means when there's a new attack that comes out, a 0-day, it either optimistically hits one of our existing regular expressions or signatures, or we have to quickly update and create a signature and regular expression for our customers to push that out to them. Imperva RASP, adding this into the mix, meant that now we have not only this methodology for detecting attacks, but a very different methodology for detecting attacks. It's a little bit like having one type of filter that looks like that, and another type of filter that looks like this. So if an attacker tries to come in, yeah, maybe they do get through one all of a sudden because they have a 0-day, but it hits the next one and gets bounced out. They have to get through two separate different kinds of filters to go through. The last point that I want to make is most of our customers are going to certainly use Cloud WAF because it has all the things we've talked about in the past that I won't go into again, DDoS, CDN, et cetera. However, most of our customers are likely to choose between either as a secondary solution, on-prem or RASP. In some cases, you might see some of your customers choosing RASP where they can for those frameworks we talked about earlier, Java, .NET. Or if they don't have, or if they have something else that's not these three, they'll use on-prem for that. The point here again is flexibility. And we even have a licensing model for flexibility called Flex Protect. And it works exactly for that reason, to give customers the availability and the technology to use what they need to use, where they need to use it. And Imperva RASP brought all this together so that we have a true layered defense, not multiple layers of the same technology, but multiple layers using different technology. Thanks.